myself, I'm a game developer and have been since about 2000. Currently working at Kuato Studios, where we make games aimed primarily at kids with an educational value. So we're currently have a couple of games out with a literacy background, and we also have a game that aims to teach the rudiments of JavaScript. Our studio develops exclusively in Unity 3D. We find it a great environment to get our products out there quickly. I myself very much enjoy rapid prototyping, and Unity's certainly been a great tool for that, and experience with RealSense has definitely sort of added to that, showing that you can go from an idea to something you can play really quickly, which is a great feeling as a developer. I'm a big fan of electronic and dance music, which might seem irrelevant, but it will become obvious what I say now. And I also love musical games and arcade games, sort of things that you can pick up quickly, learn the rules of quickly, and start to play almost immediately. So on the day at the lab in the morning, I believe we were taught quite a lot about the very powerful and quite large SDK that's available, which comes in a few different flavors. So I was mostly investigating the Unity SDK, because obviously that's where I live these days. In the afternoon, we were given some time to put together our own projects, and so one of the things, sort of from my background in rapid prototyping of sort of small ideas to turn into small usable projects, was I wanted to make certain that we could actually finish something and give everybody something to see at the end of the day. So I decided that I would do a short, fully playable game, and I also wanted to keep it quite light-hearted. We had some wonderful demonstrations from people showing you the kind of the more serious possibilities with the RealSense SDK, but I wanted to do something that sort of put smiles on faces and maybe gave people an idea of how much fun it could be as well. To begin with, did what I guess most people would do, which is to check out the demos, which are very good. There's a good range in the Unity SDK that will show you what sort of building block capabilities that you've got. You can open each of them, run them pretty much immediately, and start to wave your hands and get something moving on the screen, which is, again, a great experience as a developer to not have to wade through lots of sort of problematic setup. It was pretty quick. I had one brief problem where the SDK didn't fire up, and we discovered we needed to copy the signed drivers in. So that's a possible gotcha. If you see a lot of red error messages and you don't know why, then possibly you just need to check you've got the signed drivers. Having spun through the examples, I settled on pretty simple interaction in terms of the hand tracking. I used the send message example demo, which you should be able to see here in a second. And there you go. It's simple, it's immediate. You can see that we're getting some geometry back from my hand, and it's working as expected. No code needed to do that. Obviously, you just open it up and run it. And so I figured that would be a good basis on which to start putting some game ideas. The first thing that I did to start editing the example was to locate the hand tracking object and the scripts attached to it. So these were attached to cube, I think, and you should be able to see these components here. It's all, the example scripts are nicely laid out. You can tell what is being done everywhere. And so I got straight into creating a second copy of the object, and then using the drop downs to change how the script works. I made sure that the left one identifies as left, right one identifies as right. I also added a few physics objects in that I could use around, and I realized while I was doing that as soon as I touched things, and I was throwing all of the objects out of the universe, so I had to add some walls. And within about 5 minutes, I had a little example of something I could play with no lines of code written whatsoever, but that I could sit here and just slam these things around and get an idea for what was possible with Unity and with RealSense. And as you can see, this is immediate. I didn't write a single line of code, and this is something I can physically play with. The actual concept obviously is not going to win any awards, and it's not going to change the world, but what did make me pay attention was that while I was getting this working, the people around me were starting to snigger a little bit because it kind of looked like I was dancing in my chair. So that was good because that kind of inspired me to come up with my game idea for the afternoon, which is Rave Revolution, or Teaching the Dying Art of Raving. Really, it's actually a two-handed whack-a-mole game with some musical basis to it. You have to hit some targets as they appear. You have to hit them with both hands. It has slowly increasing levels of difficulty, and there's a scoring mechanism that works on how quickly you achieve the task. And then, because I'm from the 90s, it appears, I stuck some rave music in the background as well, just to keep things light. I will open that up now. To begin with, I needed something to actually interact with, so I was representing my hands with cuboids again. I actually tweaked the cuboids so they kind of looked a bit more like hands that you could see, which with a longer, flatter surface. I created a bunch of spheroids and I assigned some scripts to them and some colliders to them. Let's see if I can dig these out here. So these aren't complex at all, created a physics object, and then these had really small amount of setup code added to them. We're talking a handful of lines. In fact, the whole game came to, I think, about 300 lines in total. This really shows how easy it is to get something working. You're not going to be sat there all day wading through thousands of lines necessarily to get your concept working. Once I had the colliders working and some scripts to set them up, then I did the more sort of broad game logic. So I got a score device, a timer device, and I wanted to make sure that when you hit the things they registered. So I set that up with, again, not a huge amount of code in here. The first thing I needed to do really was to get one round playing where you had to hit the balls would appear in a random place, and you have to hit them with both hands, and then they would reset to a new place, and so on and so on. That gave me an opportunity to work out a few things that I needed to improve before I could really get into the gameplay. One of the things to be really aware of is that you've got a volume in front of the camera, which is the useful sensing volume. If you're planning a game where you're kind of getting people to reach up here or out here, then it's really not going to happen for you because the camera can't see that. So some of my initial ideas, I kind of had to bring it back into, you know, where can the camera see you and what kind of interactions are going to work. But once I got that nailed, it was time to actually move from a single looping level onto something more like an actual playthrough game. So I got the timer working. I tinkered with the amount of step up from the speed in each level to make it actually something of a challenge. And then I added a score, so the more quickly you actually hit the targets, then you get more score added on cumulatively. And then as the game progresses, you get less and less time, and as each round runs out, you're eventually going to find a point when you run out of time, and that's game over for you. So for some last bits in the last sort of 10 minutes that we had, added some comedy encouragement to make it a bit more jokey. I added a game over condition, which was when you run out of time. I dropped some music into the background, and I grabbed some fractals off Google image search to make it look slightly brighter, so it wasn't all grey. And then we had pretty much a playable game, which this is a static image of it, which I shall show you hopefully working. You might get the music or you might not, I'm not sure if you will. So there we go. That's one of the playthroughs of the game that I put together. It obviously needs a lot of polish, but the concept's actually quite fun. you do end up looking like you're dancing in your chair, which is kind of entertaining. And I've got a whole bunch of next steps that would hopefully make the game from the sort of playable demo that it is now into something that might be of release quality. There's the idea of linking the target hitting to the music, so you have to hit things on time. Also so that you have to achieve the postures with both hands synchronized to make it more difficult. We need to sort of tweak the gameplay there so that you can actually score more or less, because if we quantize the timing. Did think about having a shape throwing detection, so if you have people that are keen on their club life, then in between rounds you could get them to have to put their hands in a certain position and then possibly take a snapshot of them looking fairly silly in their lounge. One of the other ideas that we had was Rave face detection. So obviously another part of the RealSense SDK, even though I focused on the hand tracking section of this, is that there is a quite powerful and well-rounded set of face detection calls. So the idea was that keeping in line with the sort of club context, then you might get the player to have to sort of achieve a huge grin or do a big frown or maybe go, oh, to the music, all of which should be doable with the SDK, but I haven't got quite to that point yet. There's more work for me to do there. As well as the depth camera, obviously the RealSense camera has got a normal 1080p webcam built into it, so it would definitely be quite a lot of fun to choose apposite moments in the game to take a snapshot. There's a number of major consoles do that these days when you're busily leaping around playing, so pick a time when you've asked them to do something particularly hilarious, take a snapshot, and at the end you could get them to share that with their friends possibly on social media. And also part of the SDK that I need to explore that could add another element to the game would be to do actual gesture detection. So you could do thumbs up, you could do pointing and gun fingers. And again, this is functionality that the SDK has, which it will do a fair amount of the work for you. There's a huge amount of the SDK that I haven't actually made a use of yet, but that's all there for me to do in the future. Not revolving around RealSense, another couple of tweaks that I definitely would need to do with the game. Some multiple play, so you can play it a number of times, to add a high score table to it possibly. Definitely lots more music in there, and finally graphics that aren't made by a programmer. And yeah, at that point I think I might have something that I can put out to the world. So that's pretty much all that I need to say about my experience putting that game together.
Great.
Let's see where we're at.
Yeah. So there's someone who asked if you would be able to upload a video of a cast of your game for later, because it was getting a bit slow when you played your game. So I think some people weren't able to see how the game works exactly. So that's good.
Yeah, absolutely.
Okay, great.
Yeah, I can do that, sure.
We'll send it to everyone after this session. And also, so if anyone has questions, now it's time to ask. And if you don't, we will move on with Diana. Okay, so
hi.
Hi, Diana. So I will let you do your presentation now.
Okay.
Okay, Diana. I just made you present, so now you can start to share your screen and your webcam.
Okay.
Okay, great.
Can you see? Okay. Can you see me and my screen?
Yes, it's working fine.
Okay. Okay, good. Yeah, I'm very with what Scott did in his presentation, and I found some similar things with the RealSense about how it was relatively easy to plug in all of the drivers and get the camera actually working in a Unity scene. So I'm going to show what I did. And again, also, the first time I used RealSense, I used it with the WPF on Visual Studio. And this time I thought I'd try it with Unity because Unity has so many more capabilities now. And I don't know, can you see, I have Unity up right now. Everybody there, right? I'm here?
Yeah, it's working fine.
Okay. Okay, good. Just making sure. So when I hit play, I'll just show you what it does first and then explain what my process was. First, okay, so can you see me in the RealSense camera moving my hand around?
Yeah.
So what I wanted to explore was the 3D movement of the RealSense hand and using that to grab things in space and move them around, which well, it's not, it's kind of working on that one. Let me run another one where it's working a little better, I hope. But it's the idea of moving, picking things up in space and moving them around and what you can do with that. Okay. On this one, you pick petals off of a flower. So, you know, what's really interesting about the camera is that it does move in 3D space, which which is unique for inputs as opposed to using a touch screen. Okay. Because there are a lot of games I've played, like for instance Octodad, if you ever played that, it lets you move an object, it lets you move a character whose limbs are made of kind of chain, IK chains, you know, as though they were fabric. So you're moving their tentacles around in 3D space, but you have to simulate that by using the mouse drag and holding a key at the same time to move up and down. But with the RealSense, you can move in 3D, so you know, I thought I'd explore that especially. All right, anyway, I'm not going to play that whole thing, but I'll show you how I made it. But let me show you a really basic example of a Unity scene that uses the RealSense. This one, all it does is move a cursor around and highlight an object that is behind the cursor. So right now the cursor, it changes to crosshair, and then if I'm getting toward the edges of the play field, it changes to like a slash. So it fades from one image to another depending how close it is to the center of the screen, and then any object that it moves in front of changes color. And that was pretty simple to set up in Unity. So what it uses is, in the Unity scene, the first thing you have to have is an object that takes the RealSense camera data and initializes the RealSense manager and creates the delegates and events for all the other objects to subscribe to receive data from it. And that's just an empty game object with a script attached. So this is the script that's on that object. All it is just an empty game object, like I said, with the RealSense script. And I'm going to run it in, I use Visual Studio. Let me just update everything. So this is the script for the camera. I mean, just the RealSense camera data. And it has some public delegates, like, you know, on-hand data. Because for this, all I use for that crosshair one is just the hand data and also the depth image. And the depth image I only use to get the dimensions of the frame in order to place the hand within it. And then some events, for instance, the on-hand data event and on-depth image delegate. So these are the events that other objects can subscribe to, that anytime a piece of a frame of data is coming into the camera, it'll send it to the rest of them. And on start, you know, you initialize the RealSense manager, and you know, and then give it, I'm sorry, yeah, enable it and initialize it and make sure that it's not, there's no error. And then put in a disable method also to dump out to dispose the manager. And the manager is what acquires the frame. And the frame comes in, and basically I got most of this code from the samples that come with the SDK. You know, so then on the update, you could probably have something here to reinitialize the RealSense manager if it turned off, but here it has to be on at the beginning, so it's very, very simple just to get this whole thing. You know, this is the whole thing for the camera, just a couple of methods. So all I'm calling for here is the hand. You know, I'm just querying the hand position, but there, like Scott mentioned, there's so much else that you can access. You know, the hand, the face position, the position of each part of your face, your mouth, your nose, you know, the depth, and the also color, image, and also microphone array. So all of that you can access through, you know, these scripts. So long as you have the drivers in the correct plugin menu and everything like that that you can get from the samples. All right, so you know, you have the RealSense camera, which I mentioned in the scene, and then you need an object to get affected by it. And here I have several objects. For instance, these images. Sorry, I have two images that receive those events from the RealSense. And so I called this script the very simple hand engine, because it moves anything whenever the RealSense sends off hand data information. This hand engine will be moved by it. So it's right on that slash image on the canvas, and the crosshair has one too. The only difference is that the crosshair fades in as you go closer to another image, which is invisible, and I could place it anywhere I call it the sweet spot. So anywhere I put it, however close you get to it, you either fade in or you fade out. And then the only other thing that has an object that subscribes to the RealSense camera is this cube, which has basically a hover script on it. You know, it's a lot like a mouse hover, and it'll change color when the hand is right over it. And for that, I also needed to put a raycast, hold on, a raycaster script on the image that is being moved around by the hand. It's going to have a raycaster script on it so that it knows what objects are right behind it. And this is what will send a message to the script that's on that cube to change color. So yeah, so the cube, basically it doesn't really need to pay attention to the events that come off the sensor, because it reacts to the raycaster on the crosshair. So, you know, it's very, very basic and simple, but that's just to show you how fast you can get something that the RealSense controls, you know. And then after that, on my scene, I had something to actually grab the objects and move them around. So then you have to project the position on the screen to the world space in Unity, and that'll move it around. That's what I have in this daisy scene. In the daisy, each of the petals can receive an event from the RealSense to know where. Well, actually, these receive the ray cast from the hand. That's how they move around. That other one where you're picking up pieces of string and thread. Now this one, it uses the same basic mechanics with the cursor being moved around and then hitting a ray cast on an object. And in this case, what's receiving the ray cast are little blocks. And I'll show you the scene in just see-through wireframe so you can see. The thread is made of little interlocking chains. So each one of these fit into another one, and then they're all using a hinge joint so that it's really a physical chain, and it's using hard body physics to interact with each other, and together with the hinge connection, it moves just like a physical chain. And if you have enough of them and they're small enough, it'll behave a lot like a soft body thread, which is what this is. And then each one of these links in the chain get hit by that ray cast and grabbed and moved around by the by a hand. And the one thing that the glitch that's happening now is that I really need to have a better way to have the grab performance more reliable, because right now I'm able to pick it up now, and then drop it, but it needs to be far more reliable than it has been, because I think with these kinds of games, the interaction and how well it interacts and how predictably it interacts is very important. So yeah, that's supposed to be the end of that game. I was able to clean the lint off of the filter, or whatever you want to call that.
Okay, so thank you, Diana. I saw that we had one question.
Okay.
I don't know if you can see the questions on the panel, but I can just read it for you. It's does RealSense offer any mechanism to indicate to the user about the 3D movement, especially about the Z-axis, as the user may find it difficult to move the hand either toward the camera or away from the camera?
Yeah, there should be more of an indication of the Z, but you can put that in there. Yeah.
Okay.
The demonstration I had didn't show any interactive indication for that, but there is a Z-axis in the data, so you can put that in there to show either making the cursor bigger and smaller or changing its color also, or something like that.
Okay, great. So Ratan was also asking, how far should the displacement be?
How far should the what be?
The displacement.
The displacement?
Yes. So
For the...
How do you do your measurements in general? How do you...
Oh, in the world, I try to, when I model and when I create the world in Unity, I use their natural measurements and I try to keep things as one-to-one to reality as possible. Although in the thread example, I lowered the gravity considerably, so it's got about half the gravity of the planet Earth. And those strings are pretty large in the world, you know, they'd be about the size of ropes. But, you know, I don't know, so I use the real world size scale for Unity because I'm using the physics that comes with Unity, so, you know, that's why.
Okay.
But yeah, and then as far as how far to move things, I put in a multiplier in the data that comes from the hand, and then just kind of intuitively feel it. In Unity, I use public members so that I can change the values that I'm multiplying the movement by in the real world until I get a scale that I think works well.
Okay, great. Okay, and someone's asking if RealSense has a lag in the camera processing. How did it work?
The RealSense, no, I think that depends on your computer, on all of the, how fast your computer is, because the camera, I found it's pretty fast. It does have a jitter, you know, to the hand placement. There is a little bit of a jitter there, but the response time is pretty fast, I think.
Yeah, so it depends on your laptop. Okay, great.
Yeah.
So thank you, Diana. If anyone has other questions, you can email them to me, and I will forward them to Diana. Thanks, Diana. And now, Chris, Chris is gonna be your time to make your presentation. If you're ready.
Hey guys, can you guys see my screen?
No, we cannot see your screen right now. Ah, yes, right now we can.
There we go. Cool. So, hey guys, I am Phil Bias with Outhouse Games. We are located in Orlando, Florida. To go ahead and get rid of the one question everyone always asks us, yes, we go to Disney World absolutely all the time. You have to, it's Orlando. Let's see, the three people that helped build this game that we're about to show you is Bethany Borden. She did the audio. I did a little bit of art, and Chris Borden did the development. And he's actually going to jump in the hot seat in a couple of minutes and kind of help walk you guys through how this all works. But real quick, I wanted to kind of talk about how we got introduced to the camera. In November of last year, we were at the Intel RealSense Dev Lab. And basically during the entire day, we got about 4 hours of introduction to the game, or to the camera, and we were absolutely blown away by how easy it is to do like the hand tracking and the finger tracking, and you can actually read the emotions of the players through the facial analysis, the speech recognition, and the ability to do 3D scanning. It's an amazing system, an amazing amount of things you can do with just a couple cameras. The thing that blew us away the most is how easy it was for us to implement these things into our own games. Let's see, we were given about 4 hours at the end of the event to kind of hack something together and see what we come up with. And that's where we came up with the idea of doing Jenga, since it's a game that you really can't play with traditional keyboard and mouse and gamepad. You really have to kind of play with your hands to try to get in the 3D environment. So we sat down and started playing with it. We actually were able to get done in about an hour and a half, crazy enough, and then spend the rest of the time just polishing it. I mean, it shows how amazingly quick it is to use this system. Yeah, so I think I'm going to go ahead and hand it over to Chris and let him jump in here and give you a demo and show you how it all works.
Awesome. How you doing, guys? Yeah, my name is Chris. I did majority of the development for this game. Like Phil said, it only took us a few hours to get the prototype up and running. The RealSense API really helps out And we'll get more into that after I show you guys the demo. So we wanted to get right to that and start playing this game and show you what we came up with. So as you can see, you have an open 3D environment. We really wanted to push as far as we could in the time that we had. So we wanted to do something with both hands. So on the right hand here, we have our cursor, which we can use to highlight items and destroy the tower without doing anything, which is totally fun. But then we also are using our left hand to rotate the tower around so that you can get different angles on it and select different things from different sides. I'm going to try to set something on top. It is really hard, so just, yeah, let me see what I can do. And there you are. So you can see we got it stacked up on the top. I almost destroyed the tower, but not quite. Let's see if we can get one more out real quick. Let's see, what about this one? Oh, I ruined it. So that's our demo. We didn't add a whole lot of scorekeeping to it since the game itself is already really difficult, but that's why we wanted to do it in the RealSense camera. So let's go into Unity, and we can show you guys what we've got built here. So like we said, we wanted to build this game as quickly as possible, and we wanted to put in as little of our own code as we had to. We really wanted to work off of the RealSense API as much as we could. So one thing that the RealSense API really does well is its actions. So over here in actions, you can see we have a lot of different, there we go. You can see we have a lot of different actions. Anywhere from like deactivating objects, disabling objects, a translate, which helps you move objects, and scaling and rotating. These things are really easy to use. You literally just drop them onto the object you want to apply the movement to from the camera, and you just set up a few small settings, basically what hand you want, what kind of gestures you want to use, and then you put in your scripts on the other side of it that you want to call with that. And if you see here, we have a block movement script that we have attached to our enable and disable behaviors here. So when it receives the grab gesture, it accesses our behavior here, which is our sphere block mover, and that actually parents the block to the cursor and turns on gravity and makes it kinetic and allows us to move that object around the scene. The other ones we have are the rotations. And again, that was really simple with the RealSense cameras. I'll show you a little bit of our code for our rotates. So basically, it just calls this script once it's activated. Once the script gets activated by a gesture, either thumbs up or thumbs down with the left hand. And then we're able to rotate the game object's transform. We're actually rotating a camera spinner, and we attached our lights and our tower light, our main camera, and our cursor to it. That way we can move everything around without actually having to move the tower itself, so otherwise it might fall over. So we had to work around that little problem. But once it gets enabled, it'll rotate, and that's what you're seeing on the rotation. As far as block movements, we wait until we either receive an on-trigger enter or an on-trigger stay, because we don't know at the time the cursor is activated whether or not you're already going to be colliding with the object or whether you're already colliding with the object. So we run them both just to check. And then after you do the open hand gesture, that disables it. It unparents the block from the cursor and then reapplies gravity and allows the block to fall either to the floor or on top of the tower, which is essentially where you want it to go. But let's see, I'm going to do a little quick demonstrations like here in Unity, so you can kind of see it working here in the editor. If you look here on the right-hand side, you have this is our cursor, and we have our block movement script on it, along with our hand tracking action, which we use to move the cursor around the screen. And then we have our enable and disable behavior, which grabs and releases the blocks. So as you bring your hand into the scene, which it probably won't work, of course not. Let's see, one more time. Won't work. Let's see. No, I think it might be because I'm in the conference. Well, I'm not sure why the cursor won't work in Unity, but anyways, what happens is once the enable behavior receives its call, which is our closed gesture or open gesture or our thumbs up or our thumbs down, we actually have it activating or turning on these scripts that allow us to either rotate the cameras or parent the cursor to the blocks, which allows us to then move it. So yeah, that's it. I don't think there's anything else to show. That's the game. So if you guys have any questions, we will be making this entire build available. Yeah, we're going to make the source code available online at GitHub or something like that. If you guys follow us on Twitter, we'll let you guys know where it's going to be.
Okay, great. So I see a question from Rob, who's asking if you create your own gesture with C#, does your gesture appear in the Unity 3D toolbox so you can use it easily?
I'm sorry, you were breaking out one more time?
Yeah, so if you create your own gesture with C#, does your gesture appear in the Unity 3D toolbox so you can use it easily?
We did not create our own gestures. I actually have not played around with that part of it yet. But it does have quite a few gestures already built. Thumbs up, thumbs down, open and close hands, swiping. A peace sign, or a V for victory. Yeah, so it already has quite a few built-in gestures, so we didn't really end up building any of our own. Plus, with the time frame that we had during the hackathon, we didn't really have the time to do that. Maybe something we can in the future.
Okay, and now we have a more general question. Leo is asking, do we need any additional libraries to install in Unity for developing with RealSense?
You will need to download the RealSense API and install it. And your drivers for the camera itself. You want to make sure all those are installed correctly. We were running into problems installing, but once we figured out what we were doing and what we were missing, it all worked out perfect. It was maybe 10-15 minutes, and we figured it out. But it was actually really easy to install and to start using. It's already got its own built-in scenes, so you can try different things out really quickly. And then, like I said, those actions really make it easy to prototype. I mean, rapid prototyping is like the name of our game, so it made it very easy.
Okay, great. Okay, Sumant is asking if he can get the webinar after. So yes, this is planned. So we are going to send the webinar to everyone. We will upload it on YouTube tonight. And then if you think of any question that you haven't had time to ask today, that you would like to ask to any of the presenters, so Scott, Diana, Chris, or Phil, you can just email them to me. I will send you my email address, and then you'll have everything you need. So if you have any questions, we still have a couple of minutes. Otherwise, I would just like to let you know that we will have another webinar in October, so it's going to be mid-October. We already have 2 speakers confirmed, and still we are recruiting one more speaker. If you would like to present any project that you have done with RealSense, let me know. It would be great to have you. And thank you, everyone, and have a nice evening.
Thank you.